In this video, we'll take up the Chapter 3 review. So for the first question, we're just looking at which one represents the situation, and since you have an original population and not, and you are doubling every week, so it's the base of the power is 2. So the choice is A. Yep. For the second one, to get 4 to the power of x minus 1, you must have shifted 1 unit to the right. Because d equals 1. For 3, I drew the graph. With the graph, I'm hoping you can get the range that it's greater than negative 2, sorry. This one is just, if it's a negative exponent, take the reciprocal of the base. If it's 2 to 2x, you can use the power law of exponents to convert it to 4 to the x. So let's see, for question 6, yeah, just your exponent laws, not much to say there. But be careful, if you're adding or subtracting powers, it doesn't matter if the bases are the same, there are no exponent laws that can help you. For 7, more exponent laws, not much to say, just follow BEDMAS. I would argue like 7b, that's a grade 10 question because there's no rational exponents there. So if it doesn't involve rational exponents, I don't consider that as a grade 11 question. Same with 7c. 7a, b, and c to me are all grade 10 questions. Nothing about it involves rational exponents. So yeah, 7d is the only one that involves a rational exponent. Alright, question 8. Just establish a, k, d, and c and then state the transformations. For question 9, you have an exponential growth model. You can solve for the population in 15 years. In 15 years. And you can solve for when the population will be 500,000, but then you end up using logarithmic form. So if your calculator can't evaluate a logarithm with a base of 1.08, then type in log 4 divided by log 1.08. So it takes about 18.013 years for the population to reach 500,000. The big assumption that we make, which is probably not true, is the fact that the population is growing at a constant rate of 8% per year. So the way population growth works, it fluctuates over time. So you can go Google like the rate at which the population of Earth is growing. It's fluctuating. Basically every year it's different. Okay, so you can Google that. But we're just going to average that and say it's 8% per year. Okay, question 10, to be honest with you, is a very strange question. I don't really see the purpose, but I mean, it's good practice for your algebra, so you can try that question. But I like question 9 the most because you need to, it basically encompasses everything. You build your model, you use the model to answer your questions.